Hello. Today we're going to be looking at two exam questions, both taken from trial exams around 2019. These are the last questions of the exams and they're from exam one. So we want to note here that we're not able to use any calculator. Now, with these problems, a lot of them focus on using either exponentials with a base to the power of e or a logarithm with base e. So it's really important that students understand some basic identities with these problem types. An identity might be log e to the 1 equals 0 or log e to the e equals 1. So these things we need to, or you need to know as a student quite well. Okay, let's get into the questions. So 2019 Heffernan exam 1. This is question 10 and it's worth 6 marks. And the first part says let f equal 0 to infinity, all real numbers, fx equaling 2 log e x, and g has a defined domain, all real numbers in between there, and gx equals log e x to the minus e on 4. I would be noting that this value here, that's going to cause us some complications. So we're going to have to really make sure that our mental computations or our arithmetic is on point. Okay, so show that the solution to the equation fx equals gx equaling 1, or fx minus gx equaling 1, is given by x to the ex. There's a couple of ways that we could do this. What I would tend to do is try to solve it like a proof. So I would say 2 log e x, that's fx, minus gx, which is log e x minus e to the 4. And then I'm going to apply my logarithmic laws here. So if I apply my logarithmic laws, I get log e x squared. That's honing on this section. And because I'm minusing it, I can take it on x minus e on 4. And we're saying that this all equals 1. Therefore, I can say x squared all on x minus e onto the 4 equals e to the 1, which is e. So e to the 1, but I just don't need to show my e there. And then I'm going to write this equation as x squared equals ex minus e squared on 4. And I'll put it in terms of 0. Equals 0. What I want to recognize here is that I have a quadratic form and I want to be able to explore whether I can factorize that accordingly. If I think about this, I think I can if I say x minus e on 2, x minus e on 2 again, that factorization equals the line above us. So therefore, I can say x equals e on 2, which is what we were looking for originally. Okay, so we've done that problem. Then it says, let the area bounded by the curves y equals fx and gx and the lines x equals e on 2 and x equals e, open bracket, e plus 1, all log 4. This area is shaded in the graph below. The corner points are P, Q, R, S. Write down but do not attempt to evaluate a definite integral that gives the value of the area. So simply here, we're going to say that our area equals, we're going to put our lower and upper limits in. So we're going to say e on 2, and then we're going to say e plus 1, all on 4. And we're going to take the top curve, fx, minus gx, and we're differentiating with respect to x. And if we wanted to extend this out, all on 4, we're just going to state what fx is. So 2 log e x minus log e x minus e on 4 dx. Okay, so that's our area. Pretty simple. I believe that we could write that as our answer, but then we could extend it out. So just make note of that. Then it says the area of the trapezium PQRS is used to approximate A. The area of the trapezium PQRS can be found by using a result from part A and can be expressed in the form C1 plus log E to D, where C and D are simplified expressions in terms of E. Find C and D. Well, let's just ascertain what we're doing here. So what we're saying here is we've got a couple of points here. Okay, so this is our trapezium P, Q, R, S. I'm going to have a look at, it says to refer to part A. Part A says that when x equals e on 2, fx minus gx is 1. So therefore I can say that that length there, ps, is going to be equal to 1. That's handy to know. I'm going to say that my area for a trapezium is given as half a plus b times the height. I've got this, I can say that, I can call that a, b, and then we need to ascertain our height. Our height here, we can have a look here. So if I look here, my height is going to be the difference between those two terms. So that height is going to be minus e on 2. And I really want to find what b equals. So finding length QR. So I want to find the length of QR. What is that going to be? So I'm going to say that that's going to be 2 log e, and for x I'm going to substitute e plus 1 on 4, and then I'm minusing actually, let's take this back so that we get that there. So that's the point of q, okay, the y coordinate of q, minus the y coordinate of r. So that's going to be log e, and if I refer to it, minus e on 4. So I'm going to evaluate this now. Let me just consider what I'm going to do here. And use a logarithmic law here, where I'm going to bring my power to the front. I'm also going to consider this. I'm going to notice that I have e on 4 here. So that's log e. If I expand this out, I get e squared plus e minus e on 4. That means that I can cancel out those. Okay. And then because I'm going to continue with my logarithmic law, I'm going to say log e plus 1 on 4 all squared divided by e squared on 4. So this could be rewritten as log e squared e plus 1 squared on 16 times by 4 on e2. Get a cancellation there. I can have a look at, so just note I'm looking at 4 and 16. So I'm going to try to simplify them as much as I can. So I've got e plus 1 all squared on 4. All right. Therefore, my area of my trapezium equals a half. Okay. A I found as 1. B, the length QR, is log e plus 1 all squared on 4. And then times the height, which is e plus 1 on 4. Okay. Minus e on 2. But I might take that step back and just write that as 2e on 4. I'm going to keep this first part. Actually, I'll step this back. I know it's easy when I have a tool such as the notepad, and it's very different when you're doing the exam. If I consider what's going to happen with this, that's going to be e squared. So I'm looking at, so just so that you understand, I'm looking at simplifying this term. I'm going to look at that as z squared plus e minus 2e. That gives me minus e all up, all on 4. 1 plus log e plus 1 all squared on 4. Okay, equals e squared minus e on 8. That's when I carry the half through. 1 plus log e plus 1 all squared on 4. Okay, and then I'm going to have a look. Do I have it in the form that they've been asking? I do, so I'm just looking at this form. So therefore, I will say that C equals E2 minus E on 8, and D, remember D is talking about this term, which will be this term here, E plus 1 all squared on 4. Not an easy question, one that you're going to have to really make sure that your arithmetic and understanding of logarithms is really on point. Okay, so going to our next question, we're looking at the 2019 Insight exam. And what we have here is some function f, and the domain is 0 to a, all real numbers. Fx equals the square root of negative x cubed plus kx, where k belongs to all real positive values. Okay, we'll want to notice here that the range, okay, is all positive, or the range is 0 to infinity. That's important because I want to find my intercepts of this value. So essentially what I'm saying is 0 equals the square root of negative x cubed plus kx squared. Okay, this is 0 equals negative x cubed plus kx squared. I like to always just have the positive leading, even though it's not the higher coefficient. And I can take a factor out of here of x squared, and then I can say k minus x. Therefore, x equals 0 or x equals k as a value. Therefore, if I consider that my domain is stretching from 0 to a, and that's what's shown here, I therefore need to say that k equals a. Okay, moving forward. Then we're saying that P is a point on the graph of y equals fx with the coordinates P, Fp. Show that the length of the chord OP is given by the expression there. Just remember here your distance equation is going to be x squared minus, oh, let me just start that again. x2 minus x1 all squared plus y2 minus y1 all squared, and everything square rooted. That's just our distance of equation. I'm going to say that my length then is going to be the square root, and because I'm going from the origin, it makes it a little easier for us to determine what this is going to be. So when I focus on my x values, well, what I'm saying here is in my graph, I have some point P, Fp, or this could be P, and then if I write it as minus P cubed plus Kp squared, and we're saying that that's the length there, because I've got 0, 0, all I'm doing is really honing in on these coordinates. So when I go to my equation, when I think about my x2 minus x1, this is just going to be p squared. And then I'm going to be adding this square of this term. So minus p plus k plus 1 p squared. And that's going to be squared. This gives me L equals p squared, all square rooted. Sorry, program I use likes to do that. Okay. Minus p cubed plus, sorry, let me take this back. That's what we're trying to find. That wasn't the value here. So what we have is square root minus p cubed plus kp squared. So that just becomes plus kp squared. Okay, all squared is get rid of the square root. Therefore, L square root, I can say minus p cubed. Then I can have a look at this common factor, p squared. Okay, that gives me k plus 1 or p squared. And this is the term that we've been looking for. So that's the length of it. Okay. Then it says for 0 or k in between 0 and 2, The chord OP is longest when P equals K. Determine the value of P for which the length of the chord OP is longest in terms of K when K is greater than 2. So this is an optimization problem. So what we're looking to do is to differentiate L, the length. What I'm going to do is I'm just going to notice this, that I'm going to put minus P cubed plus K plus 1 P squared. And I'm just going to write it as a half. This just helps us to use the chain rule to differentiate. So I'm saying dl dp. And what I'm going to do here is I'm going to find the derivative of the bracket. So actually, first things first, I should bring the power out the front. Then find the derivative of the bracket, minus 3p squared, okay, plus 2k plus 1p times minus p cubed plus k plus 1 p squared negative a half. It's really important that you get familiar with being able to differentiate using the chain rule without having to use u equals this, v equals this. In this kind of bracket scenario, you should be able to write it down in one line. So dl dp is going to equal 1 on 2. And I'm going to have here minus 3p squared plus 2k plus 1p. And then square root, that's coming from the negative a half there. So negative p cubed plus k plus 1 p squared. That's my expression for the derivative. Now, the thing that we're going to try to do with the derivative is make it equal to 0. And what I want you to note here is that when you're making it equal to 0, then you're just focusing on the numerator equaling 0. So these are all just quick tips to, especially when you're working without a calculator. P, I can take a factor of P out. Have that term. And therefore, P equals 0. And I can say 2k plus 1 minus 3p equals 0. And this will give me p equals, just thinking, 2k plus 1 on 3. All right. And then we have to decide which value that we're going to take. So we have to note that k has to be greater than 2, therefore, okay, and p equals k. So therefore, this cannot be, this value cannot exist. We must take this value. So we would say p equals 2k plus 1 on 3. All right, that's it for today. Please make sure that you revise your log laws, use of logs, log identities. You need to understand all of those. These kind of questions at the end of the exam, it's really important that you are on point. They're really trying to differentiate which students are going to get the full marks of the exam and those that aren't. So timing is key here. You know, but just step by step, take step by step, get as much marks as you can. Each step will get you further towards getting more marks and maximizing your score. All right.